All right, should we do some chem? We're going to get it done in 55 minutes. All right, redox equations. So pretty much all of this we've seen in the past, so I'm not going to really go over it. We can skip over that. We're going to go through, this is the one, and this is I think I've got a poll for this. All right, so question 22, I'm going to give you a moment to, question 22, I'm going to give you a moment to work it out. All right, so there's a poll to vote for question 22. I'm going to give you a moment to work it out because we only just started back. So copper 2 chloride and potassium chloride. So what's that's telling us, once I get rid of the line there, copper 2 chloride, potassium chloride. So we're going to have, so CuCl2 and KCl, and they're all going to be dissolved. It says aqueous solutions, which means they're dissolved in water. Okay, so you've got the ion form, ION. So chlorine there, copper as ions there. We've got chlorine again, and potassium, which is way down here, down the very bottom almost, just above lithium. So there's the three species we have. We also have water because it's in water. So therefore, any water is available to react. So that water can react. Where else? This water can react, not this one. And that's because this water requires oxygen. So you can forget about this. Water requires oxygen to react, and we don't know if we have oxygen. Like water's got oxygen in it because oxygen dissolves in water and in the air. But in this equation, we're not told we have oxygen, so therefore we can't assume it. Okay, so you don't have to worry about this equation. Most of the time, you can cross this equation off. Most of the time, you can cross it off because oxygen and water, but they're not always. So we've got copper, chloride, and potassium and chloride. We go through and we say, okay, we've got chlorine ions, which is here, up the top. We've got water up the top, right? We've got copper 2+, and we've got water down here. And we also have potassium down here. So now we need to work out which of the following would happen, okay, over a period of time. So would you get a reaction occurring? So potassium could react. Would it be? Could potassium react? Could potassium be oxidized or reduced? Potassium could be reduced, but it would need to oxidize something like maybe the water up here. So it's possible, but let's go through the options. There'd be no reaction, okay? Maybe. Bubbles of hydrogen would appear. So if hydrogen's appearing, it's hydrogen gas. Could we get bubbles of hydrogen appearing? Probably not, because we haven't got any hydrogen ions, do we? There's no, it's hard to see, but if I zoom in, there's no hydrogen ions here. I'll zoom a bit more. No hydrogen ions. So we can't get bubbles of hydrogen occurring, really. The pH of the solution would decrease. Well, if the water goes back this way, maybe, but is the water reacting? Well, we don't know. So it's not really an option. The solution will become more intensely blue in color. So copper is an ion. Copper is an ion, which is a blue color. So the copper ion there, it would be reduced, if anything, wouldn't it? It would undergo reduction. So it would actually become less blue. So that can't be true if it did undergo reduction. So the only one that satisfies here, the most likely one to occur is the copper undergoing reduction with the water. So why does this copper react with water? Why does not the potassium or this water not react? Why do these ones react? Any idea? No one's giving me anything. Are we awake? Are we still here? Anyone? Yeah, weaker oxygen, weaker reductant. Cool. All right, took us a while. But this one here, this is the stronger, more able to gain electrons. This is more able to lose electrons. So this one takes place here. But that doesn't follow the correct schematic, does it? That's not going to react, is it? Or is it? So will the copper reduce and will that water oxidize? Is that true or not true? No, it can't. It won't oxidize. So that won't occur. So I'm going to put a cross through that. Just erase it, didn't work. So this here has no reaction. Not going to react because they're on the wrong sides of the equation. If the water was over here and the copper was over here, yes, it could work, but it's not going to. So no reaction is the answer for 22. All right. We're going to skip 23, but it's the same process. You go and you look, magnesium metal, so magnesium solid, and iron, Fe3+. Remember that 3? Yep, okay, good question. So alkaline. So the pH of the solution would decrease, which would mean there becomes more hydrogen ions, more acidic. So that reaction is not going to occur. The only reaction that would occur is this water gaining electrons to becoming hydroxide, so to become less acidic, so to become a higher pH. So 0.83, negative 0.83, that water could be reduced and this water could be oxidized, but they cancel out the amount of hydroxide and hydrogen ions. So there'll be no change in pH. All right, so that one there, balanced equation for magnesium and iron, and you also have water because it's dissolved in water. All right, we're going to skip that one. I want to do 25 together. So we're going to skip this. So you got iron 3+ because there are 3 lots of chlorine and chlorine is 1-. You'll also have water, so use those to help you. We're doing 25 together though. A steady stream of oxygen and chlorine gas, so O2 and chlorine, are passed through an acidified solution, so acid means protons, hydrogen ions, of magnesium chloride. It's a solution, so it's magnesium ions and it's chlorine ions. Okay, so we've got chlorine gas, we've got oxygen gas, we've got hydrogen ions, we've got magnesium ions, and we've got chlorine ions. There's a few species in here to take reaction, part in the reaction. So you've got to circle everything, and we've got to look at right equation for reaction if one occurs. So we circle it. We've got chlorine ions. Just make this a little clearer. So come on, pen. Chlorine ions there. Chlorine gas. Oxygen gas. We've got hydrogen ions. So probably at 0, this is the hydrogen ions. I know it's difficult to see because I'm not zoomed in. I might go in a little bit more, maybe like that. That works. So hydrogen ions there at 0, hydrogen ions. You also have hydrogen ions here, and I guess you have hydrogen ions up here as well. Okay, then we have magnesium, which is down here, 2+, it told us, ions, and we have chlorine ions already circled. So there's all the species. And then there's also water. So this water could react. And then we could also have this water now because we have oxygen gas as well. And therefore we could have this water too. And then this one as well, but that's peroxide, so we'll stay away from that. So we've got those 3 waters. 1 water there, 1 water up the top at 1.23 volts, and 1 water here at 0.4, positive 0.4. Yeah, okay, that's a good question. Ben asked, is it important to know element colors? It is a little bit, not every element, but the main elements, yeah. They have in the past given questions where they've had a nickel solution. They told you it was green and they've given a copper solution. You probably should know that copper is a blue color, but nickel is not expected knowledge, but they've told you it was a green color. And then as the reaction went forward, it became more green. And so you're expected to be able to do that. So yeah, fair enough. So the question was, are we expected to know the colors of elements? To an extent, yes. So the main ones, okay, and what are the main ones is the question. So copper, you should know the color of copper in solution, blue. You should know the copper later in the year. Dichromate, which is a purple color, permanganate's a purple color, dichromate's orange, but you'll come to those in this year. You'll do them this year. But definitely copper ions in solution, that's one you should know. You have to know them because if there's a color change, it tells you there's probably reduction or oxidation happening. And then that can give you a clue as to what's going on. I think it was like 2018 or 2017 exam, multiple choice, some question was the nickel one. You'll see it when you do your exams later this year. All right, so there's all the species there. So now we have to look, what kind of reaction could take place? So can anyone help me? What reaction can take place? Look at all the species. Remember, it needs to be on the top left, goes to the right. So A, 2 plus or A plus goes to A. And then that, if you draw the Z there, you have the B solid going to B 2 plus. So which of those satisfies? Chlorine in water? Yep. So this chlorine here could gain electrons from water over here. So this water could lose electrons to the chlorine. What else could occur? Anything else happen? Chlorine and H2O. So the chlorine could gain electrons from water. Yeah. Cool. So what we would have a reaction, we'd have chlorine gas. As it told us it was bubbling chlorine gas. It gains electrons and goes and forms 2Cl minus, aqueous. Then the water, so that's that equation there, that's undergoing reduction. That equation there. Then the other equation is the water, which is, I'll write down the E naughts so you know exactly where they are on the table, which goes to, now this is really key. Can we pay attention here? Because this is really key. I hope I got some attention. When you do a reaction like this, when it's oxidation or reduction, it's got to be a single arrow. You absolutely have to do a single arrow. Only a unidirectional arrow, not a bidirectional, not both ways. So the reason here, these are bidirectional or equilibrium arrows, because they're saying it can go either way. When you write an equation, it's wrong to write oxidation reduction with the arrows both ways. So you need to put them a unidirectional. Notice how my arrows only go one way. They're a shocking arrow. I need to work on my arrow skills. I know that. But you still, as an examiner, if you were marking my work, you could see what I was trying to get across. Okay, we don't want to unfairly penalize you, but if you've drawn an arrow that's not unidirectional, then it's not going to be correct. So water goes to oxygen gas plus 4 hydrogen ions, aqueous, plus 4 electrons. Don't need to worry about the electrons not being balanced because we're not doing an overall equation just yet. Okay, so that's the equation there. When you combine them together, it goes chlorine plus what? What comes next? Water. Yep. So the first thing, I jumped ahead, but the first thing is that we should multiply this whole equation by 2. We should multiply this whole equation by 2. Why should we multiply that by 2? Why should we multiply this equation here by 2? Yeah, to balance the electrons, because remember there's 4 electrons here and 2 electrons here. So in order to have them the same, we need to multiply this equation by 2. So 2 chlorine plus 4 electrons, because we multiplied everything by 2. The electrons will cancel out in a moment. Plus 2 lots of waters, which then goes to 4 lots of chlorine minus, put states in a minute, plus oxygen gas, plus 4 hydrogen ions, plus 4 electrons. Cancel the electrons on both sides because they're common. So we get 2 chlorine gas plus 2 H2O or 2 waters, liquid, a one-directional arrow, 4 chlorine minus AQ plus oxygen gas plus 4 hydrogen ions, AQ, aqueous. You need states, that's key. That equation would be worth 1 mark. If you didn't have states and if you didn't have the species correct, you'd lose a mark. What's happened there? Just pin this up across. Don't want that. AQ. So I'm going to try and make this single arrow. And then maybe do it like that. No, I won't do that. I'll get rid of that, basically. All right, so what's happening at the anode and what's happening at the cathode? What's the anode and what's the cathode? Which reaction's which? All right, awesome. So oxidation at the anode. So we're just going to zoom out a little bit and write it down here. Oxidation is at the anode. So what's occurring there? And reduction, don't know why I'm turning the volume up or tapping the volume, is the cathode. So what's occurring at the anode? Awesome. So chlorine. No, it's not occurring at the anode, is it? Chlorine's at the cathode. There we go. So chlorine reduced to 2 chlorine minus at anode. I haven't written the whole equation. I just wrote the basics of it. And water, what are we doing? No, it's cathode. Sorry, I wrote them around the wrong way. This should be down here. Sorry. Okay. So water there, 2H2O is oxidized to O2 plus 4H plus 4 electrons. And then at the cathode, we have chlorine being reduced. So chlorine gas gaining 2 electrons and going and forming chlorine ions at the cathode. All right, so you need to know what's happening. You need to know what's happening. Oops, it might be because I've zoomed in and out, but yeah, just refresh the browser and you'll be able to get back access to it. So how we did it. Look at all the species. Bang, oxygen, chlorine, hydrogen ions, magnesium, chlorine ions there. So oxygen gas rather, chlorine gas, hydrogen ions, magnesium ions, and chlorine ions. Does it follow this formula where the top left goes to the right and the bottom right goes to the left? Well, chlorine here as a gas, chlorine gas here can gain electrons to form chlorine ions. I'll get to your question in a sec, Rami. Then water here loses electrons to oxygen and water. Oxygen and hydrogen ions, my mistake. Then from there, you need to balance the charge on the 2. So zooming back out. Balance the charge by multiplying by 2 to make the electrons the same. 4 electrons there, 4 electrons there when you multiply by 2. Then you put them all together and you cancel out. So electrons cancel out. And therefore, we are left with 2 chlorine gas plus 2 water, which goes to 4 chlorine minus plus oxygen gas plus 4 hydrogen ions. And that's the equation occurring at the anode and cathode. Yeah, the other reactions, not happening. So this would be the predominant one. You could also get some of this water reacting with this water here. That would be possible. And some of this hydrogen ions could react, but you need more energy to do that. All right, magnesium is not the strongest, and neither is water here. So these ones won't gain electrons more favorably. The oxygen will gain electrons, the chlorine will gain electrons most favorably because it's the strongest oxidant, and this will lose electrons.